We've all seen the scene. A panicked passenger or a sophisticated villain reaches for the lever on an airplane door mid-flight. They heave the handle, the door swings wide with a cinematic whoosh, and suddenly, the cabin is a vortex of flying peanuts, loose luggage, and screaming people being sucked into the abyss. It's a staple of action cinema, designed to make your heart race. But if you've ever sat in an exit row and looked at that heavy handle, you might have wondered, could someone actually do it? Could a single person, in a moment of madness, jeopardize an entire flight? The answer is a resounding no. And the reason isn't a mechanical lock. It's the weight of the sky itself. When you are cruising at 35,000 feet, you are in an environment that is fundamentally hostile to human life. The air is too thin to breathe, and the temperature is a bone-chilling minus 60 degrees Fahrenheit. To keep you comfortable and alive, the aircraft creates an artificial environment inside the cabin. This is pressurization. But this life-saving feature does something else. It turns every door on the aircraft into a structural component held in place by thousands of pounds of force. In real life, an airplane door mid-flight isn't a door. It's a pressurized seal that no human being on Earth has the strength to break. To understand why that door is going nowhere, you have to think of an airplane not as a bus with wings, but as a giant aluminum balloon. At sea level, the air pressure inside and outside the plane is the same, roughly 14.7 pounds per square inch, psi. But as the plane climbs, the air outside gets thinner and thinner. To keep you from passing out from hypoxia, the jet engines bleed off some of the compressed air they inhale and pump it into the cabin. By the time you reach cruising altitude, the altitude inside the cabin is kept at the equivalent of about 6,000 to 8,000 feet, while the plane is actually at 35,000 feet. This creates a massive pressure differential. The air inside is constantly, violently, trying to push its way out to the lower pressure environment outside. Let's look at the numbers, because this is where the Hollywood myth falls apart. A standard commercial airplane door is roughly 6 feet tall and 3.5 feet wide. That's about 3,024 square inches of surface area. At cruise altitude, the pressure difference between the inside and outside of the cabin is typically about 8 pounds per square inch. If you multiply that 8 pounds per square inch by the 3,024 square inches of the door, you get a total outward force of over 24,000 pounds. That is 12 tons of pressure. To open that door, a person would essentially have to be able to bench press 2 full-grown African elephants. No matter how much adrenaline is pumping through a passenger's veins, the biology of the human body simply cannot overcome the physics of the atmosphere. Even if you were the strongest person on the planet, the mechanical design of the door would still defeat you. Most commercial aircraft use what is known as a plug door. Look closely at how a cabin door operates next time you board. It doesn't just swing open like the front door of your house. To open, the door must first be pulled inward, rotated slightly, and then maneuvered out through the frame. Because the door is slightly larger than the hole it fits into, the internal pressure acts like a giant hand, slamming the door into its seat. The more pressure there is inside the cabin, the tighter the plug is pushed into the frame. It is self-sealing. Attempting to open a plug door at 35,000 feet is like trying to pull a drain plug out of a full bathtub from the bottom while someone is standing on it. If you want to visualize this at home, think of a vacuum-sealed jar of pickles. When you first try to turn the lid, it feels stuck. Why? Because the pressure inside the jar is lower than the atmospheric pressure outside, which is pushing down on the lid, sealing it shut. On an airplane, the roles are reversed. The high pressure is on the inside, but the result is the same. The pressure difference creates a physical lock that is far more reliable than any deadbolt or electronic latch. Now, you might be thinking, wait, I've seen flight attendants open the door as soon as we hit the gate. That's because the aircraft is designed to depressurize as it descends. As the plane gets closer to the ground, the internal and external pressures equalize. By the time the wheels touch the tarmac and the fasten seatbelt sign turns off, the pressure differential is zero. At this point, the 12 tons of force have vanished, and the door can be opened with a simple mechanical lever. But as long as that plane is high in the thin air, the door is effectively part of the fuselage. But let's play what if. What if the door did open? Movies suggest that everyone is immediately sucked out into the sky. In reality, while it would be a catastrophic event, it's not exactly like the movies. If a door were to fail, you would experience rapid decompression. The air inside would rush out until the pressure equalized, creating a massive, momentary wind and a drop in temperature. However, unless you were standing directly in front of the opening and not wearing a seatbelt, you wouldn't necessarily be sucked out. Once the pressure equalizes, which happens in a matter of seconds, the sucking force stops. The real danger wouldn't be falling out. It would be the lack of oxygen and the extreme cold. This is why oxygen masks drop immediately, to keep you conscious while the pilots perform an emergency descent to thicker air. While physics does the heavy lifting, engineers don't leave anything to chance. Airplane doors are equipped with a series of mechanical and electronic locks. There are flight locks that engage as soon as the engines reach a certain thrust or the landing gear leaves the ground. These are controlled by the airplane's computer system, the avionics, and serve as a secondary backup to the pressure seal. Even if the plane were at a low altitude where the pressure was equal, a passenger still couldn't just pop the door, because the mechanical locks would require a specific sequence of electronic overrides that only the cockpit or flight crew can initiate. There is a poetic irony in aircraft design. The very thing that makes high-altitude flight possible, the compressed air that allows us to breathe and stay warm, is the same force that provides our ultimate security. We often worry about human error or malicious intent, but in the case of the cabin door, we have delegated the security to the laws of thermodynamics. Physics doesn't have off days, and it doesn't get distracted. It is a 24,000-pound bodyguard that flies with you on every trip. So, the next time you see a nervous flyer looking at the exit door, or you watch an over-the-top action movie on your tablet, you can smile. You know that the door isn't just closed. It is effectively welded shut by the weight of the atmosphere. Everything about that door, from its shape to the air you're breathing, is designed to keep you inside and the vacuum outside. You are safer in that pressurized tube than you are in almost any other vehicle on Earth. Aviation is full of these invisible safety features that we take for granted every day. From the way wings are shaped to the way doors are plugged, every inch of a modern airliner is a triumph of engineering over the elements. If you love learning about the hidden science of the skies, make sure to hit that subscribe button. Join us as we continue to explore the incredible world of Aero Explained. Safe travels and keep looking up.